समझ में आया? गॉस लॉ ने सिंपली आपको एक लाइक फ्लक्स बताया है. सिंपली ही डिफाइंस द फ्लक्स. कैसे फ्लक्स कैलकुलेट करते हैं, व्हाट यू मीन बाय फ्लक्स, एंड व्हाट इफ द सरफेस इज क्लोज्ड देन व्हाट हैपन, इफ द सरफेस इज सिमेट्रिकल और अनसिमेट्रिकल, तो फ्लक्स कैसे कैलकुलेट करेंगे. दिस इज ओनली द गॉसेस लॉ एक्सप्लेन. ओके, so application of Gauss's law, basically electric field due to his application is used to calculate electric field due to infinite straight wire. Right now suppose you have a straight wire, infinite, you don't know like how much long it is, 1 meter, 2 meter, 1000 meter, you don't know the length. Okay, infinitely long wire you have. Okay, and if you want to calculate the electric field of that wire, because if it is a wire obviously it has a charges, if it has a charges obviously it has electric field, right? So how much electric field is there in an infinitely straight wire, that you can calculate using this Gauss law. Similarly, electric field due to infinite plate sheet. Now suppose you have a plate sheet, एक आपके पास जैसे A4 शीट होता है ना, तो सपोज यू हैव अ A4 शीट. ओके, सो व्हाट विल बी द इलेक्ट्रिक फील्ड ड्यू टू अ इनफाइनाइटली शीट, प्लेट शीट. ठीक है, इलेक्ट्रिक फील्ड ड्यू टू थिन स्फेरिकल शेल, एक पतले से स्फेरिकल शेल में इलेक्ट्रिक फील्ड कितनी होगी. सो विद द हेल्प ऑफ गॉस लॉ यू आर एबल टू कैलकुलेट द इलेक्ट्रिक फील्ड लाइक दिस. Now, electric field due to infinite wire, right? Electric field due to infinite wire. So, let us see, first of all, the first is electric field due to infinite wire. Now, suppose this is your wire. So, this wire seems to be a cylindrical, it just you take like ये एक infinite wire है. तो अगर एक कोई वायर है, आपको सिर्फ इलेक्ट्रिक फील्ड इतना कैलकुलेट करना है, this much only you want to calculate this much. Okay, so consider a thin wire which is infinitely long and has a linear charge density lambda. So do you remember that a linear charge density lambda is equal to what? dq by dl. That means I'm talking about now the small length, right? ये तो infinite है, but उस infinite wire में हमने एक छोटे से length पे charge electric field calculate करना है. तो lambda is equal to, now suppose you have taken this one length L, and in this, at this much length you have these many charges, and due to these charges you have a electric field moves outward, electric field line निकल रही है, right? To compute electric field we utilize a cylindrical Gaussian surface. So now to calculate the electric field, you just imagine that it is a cylindrical surface. The flux through the end of the surface will be 0 since the electric field E is radial. So now what happened? The flux through the end of the surface. Now if it is a cylinder, अगर ये एक cylinder है, right? So the flux through the end of the surface will be 0 since the electric field E is radial. तो अभी यहाँ पे क्या हो रहा है? यहाँ पे इलेक्ट्रिक फ्लक्स 0 हो जाएंगे. Why? Because it is radial ना, ये तो रेडियल हो रहे हैं, कुछ अंदर जा रहे हैं और बाहर निकलेंगे, तो सब एक दूसरे को कट कर देंगे. ठीक है, बट यहाँ पे क्या हो रहा है? इफ दिस इज अ लीनियरली चार्ज डिस्ट्रीब्यूशन यहाँ पे, सो विद दिस यू हैव अ परपेंडिकुलर इलेक्ट्रिक फील्ड लाइन. द कर्व्ड सिलेंड्रिकल सरफेस हैज सरफेस एरिया 2 पाई RL. तो इनका जो सरफेस एरिया है वो क्या हो जाता है? 2 पाई RL, राइट? 2 पाई RL ही तो होता है सिलेंडर का सरफेस एरिया. द इलेक्ट्रिक फ्लक्स flowing through the curved is equal to E into 2 pi RL. तो अब यहाँ पे जो इलेक्ट्रिक फील्ड होगा, राइट, द इलेक्ट्रिक फ्लक्स इज इक्वल टू व्हाट, E डॉट A, राइट, E डॉट 2 pi RL. We can write down like that electric flux will be. तो according to Gauss law, इलेक्ट्रिक फ्लक्स इज इक्वल टू Q by epsilon नॉट. गॉस लॉ के अकॉर्डिंग इलेक्ट्रिक फ्लक्स क्या होता है, इट इज Q by epsilon नॉट, राइट. तो नाउ E 2 pi RL, this in place of phi, just write down 2 pi RL equals to Q by epsilon naught, right. Now just from here calculate the value of E. अभी यहाँ पे कैसे निकलेगा, 2 pi RL. Now L cancel, right, and from here what you can write down, see, now E equals to lambda, right, lambda by 2 pi R epsilon naught, right. So this is the electric flux due to infinitely straight wire. तो एक infinite straight wire के लिए if you want to calculate the electric field, right, so you can use this formula lambda 2 pi R epsilon naught, and lambda is what, dq by dl, you know that, okay. So this is the electric field due to infinitely long wire. Am I clear, everyone? Okay. Now, it's important to note that if the linear charge density is positive, right? So what happened? If the linear charge density is positive, right, the linear charge density is, suppose if it is a positive, then what happened, the electric field line moves outward. But if this linear charge density is negative, then what happened, it will radially moves inward, right, it will move inward. The second application is electric field due to infinite plane sheet. Electric field due to infinite plane sheet, right. Now suppose this is your sheet, okay, and this sheet is full of charges, right. This sheet is what, full of charges. Obviously it is full of charges, right. Now what you have to calculate, you have to calculate the electric field due to this infinitely plane sheet. तो अब यहाँ पे हम क्या करेंगे, एक छोटा सा एरिया लेंगे उस प्लेन शीट का, right. So just take a small area of that plane sheet. Consider a infinite plane sheet, cross sectional area A and a surface charge density sigma. We have already learned that in the continuous charge density sigma, right. So sigma is what, surface charge density. The electric field generated by infinite charge sheet is perpendicular, तो वो तो होगा ही. Consider a cylindrical surface whose axis is perpendicular to the sheet. तो see here you can just imagine a cylindrical surface जो कि from where you have electric field perpendicular to the surface, right. This is the small area element A and this is the Gaussian surface. This is your sheet having what, sigma as a surface density, okay. Now see, if this is a positive charge, ठीक है, ये अगर है तो यहाँ पे जो electric field lines है, now consider the electric flow from the two end of imagined Gaussian surface, right, when discussing net electric flux. Now we may explain it by the fact that the curved surface area and the electric field are perpendicular to each other, resulting in zero electric flux. So what happened here? The curved surface area and the electric field is what? Perpendicular to each other, and if it is perpendicular to each other, it means it is 90 degree, and cos 90 degree is what, 0 only. तो ये तो पूरा 0 ही हो जाएगा ना. If it is perpendicular, then here what, the value becomes 0, right? The net electric flux is EA minus EA. एक उस डायरेक्शन में भी जाएगा और एक बैक डायरेक्शन में भी जाएगा, राइट? सो हियर यू हैव 2EA. सो 2EA इज इक्वल टू सिग्मा ए एप्सिलॉन नॉट. तो बस यहाँ पे यही चीज आपको याद रखनी है कि हियर द फ्लक्स इज व्हाट, 2E into A, right? Now in place of flux, what you can write down? You know that flux is equal to what? EA. So here 2EA equals to now sigma A by epsilon naught, right? ये कैसे आया? You all know that according to Gaussian surface, flux is equal to what? Sigma by epsilon naught. Sigma A by epsilon naught. This is only na according to Gaussian surface. So 2A in place of flux, what you have to write? Sigma A by epsilon naught. Now area by epsilon naught. So from here area and area cut down, and what you will get, E is equal to sigma by 2 epsilon naught, right? So this is the electric field due to plane, infinitely plane sheet. So whenever you will get a question, right, in a numerical, to infinitely plane sheet, calculate the electric field, infinitely plane wire, calculate the electric field. So you have to remember these formula. अब तो याद करने की भी जरूरत नहीं है, you can निकाल भी लोगे, but it's better to write down somewhere, make a list of all the formula and try to revise it again and again. Okay? Then electric field due to thin spherical shell, right? So here consider a thin spherical shell. एक thin spherical shell है, ठीक है, with radius r, right? Charge Q and the surface charge density sigma. So what happened? Now suppose in this shell you have a charge Q and the surface charge density is equal to sigma, right? And you know what is surface charge density? Surface charge density is what? Q upon area, right? And suppose if this is the charge Q and the area of a sphere is what? Sphere is 4 pi r square. So this is the value of your surface charge density. This will be the surface charge density only. The shell poses spherical symmetry. और ये जो शेल है वो स्फेरिकल है, तो स्फीयर का जो एरिया होता है वो 4 pi r square होता है. तो in place of area you can write down that. The electric field now you have to calculate it in two ways. One outside the spherical shell, another inside the spherical shell. So now अब electric field you have to calculate in two method. एक तो सरफेस के बाहर आउटसाइड द शेल और एक सरफेस के अंदर, right? Like suppose I am not having any ball, but suppose this is a sphere like a structure. So outside also you have to calculate, and within the inside also you have to calculate the electric field. So first of all, let us calculate the electric field outside the spherical shell. So take a point P outside the spherical shell. Now suppose this is your spherical shell having the radius r. Take a point P outside the spherical shell at a distance r from the center of spherical shell to get the electric field. Okay, तो आप कोई सा भी एक point P ले लीजिए, ठीक है, which is a small r. We use a Gaussian surface, spherical surface with radius of r and center O. Because all points are equally spaced. देखो अब यहाँ पे हम किस point की बात कर रहे हैं? नाउ सपोज दिस इज योर पॉइंट P, कोई भी एक पॉइंट P ले लो जो स्मॉल r से है, तो सभी पॉइंट स्मॉल r सभी हर पॉइंट पे, राइट. नाउ इट इज अ गॉसियन सरफेस विथ रेडियस r, सेंटर O, because all points are equally spaced r from sphere center. The Gaussian surface will pass through P and experience a constant electric field all around. तो हर जगह आपको एक constant electric field ही देखने को मिलेगा. So the total electric flux is equal to what? E into A. E into A. Sorry. According to Gaussian surface, according to Gauss's law, the electric flux is equal to what? Q by epsilon naught only, right? And also you know that electric flux is also what? According to E dot A equals to Q by epsilon naught. Now in place of A, 4 pi r square you can write down Q by epsilon naught, right? So from here what you can calculate? You can calculate the value of E, Q by 4 pi epsilon naught r square. Q by 4 pi r square, right? And here, since you are talking about a surface charge density, so it is sigma only. It is sigma only. And what is sigma, guys? Here you can also write down the sigma. Okay. Sigma 4 pi r square. Sigma is into A ना, वो जो charge है. See. यहाँ पे देखो. Phi is equal to, according to Gauss's law, phi is equal to surface charge density Q by epsilon naught. Right? Now we know that this surface charge density is already we can calculate it. We have calculated Q by A, 4 pi r square. We have already calculated this value. We know. Okay. Now here what you can write down? E into 4 pi r square equals to, see, in place of sigma write down Q by 4 pi r square, right? Here multiply Q epsilon naught, right? So now surface charge density multiply 4 pi r square epsilon naught. So from here, no, don't do like this. See, from here you can take the value of Q, sigma into 4 pi r square. From here you can calculate the value of this charge Q na. So what you have to write down? From here just write down the value. Sigma in place of Q, since it is Q by epsilon naught, so it is E into A. In place of Q write down sigma into 4 pi r square by epsilon naught. Here also you have E into 4 pi r square equals to sigma into 4 pi r square epsilon naught. So this value cut down, right? This value cut down. So what you will get? E is equal to sigma by epsilon naught. Simply what you will get? Sigma by epsilon naught, right? And then electric field can also be written as sigma is equal to 4 pi r square. So electric field outside the shell is E is equal to KQ r square. तो इसको see, सिर्फ आपको ये फॉर्मूला याद रखना है, ठीक है? हाउ टू कैलकुलेट दिस. डिराइवेशन तो इतना नहीं पूछेगा, बट येस यू हैव टू अंडरस्टैंड द फॉर्मूला. ऑलराइट, तो ये सारे फॉर्मूले आप याद कर लीजिएगा. डायरेक्टली यू विल गेट अ क्वेश्चन फ्रॉम हियर. ओके, ये फॉर्मूला इसके लिए, आउटसाइड के लिए E इज इक्वल टू के क्यू बाई आर स्क्वायर. E into A, 4 pi r square. Now it is sigma 4. This is the value of Q, right? This is the value of Q by epsilon naught. So from here, what you can get? E is equal to sigma. This is capital R square. That's where I'm just getting confused. capital R square, this is a small r square. So sigma capital 4 pi cancel out. Okay, sigma r square epsilon naught small r square. Now electric field also be written like this. Sigma is equal to, from here you can also write down Q is equal to 4 pi r square, right? So in place of 1 by 4 pi epsilon naught, 1, see K is equal to what? 1 by 4 pi epsilon naught, this na. So in place of this 1 by 4 pi epsilon, you can just write down Q, and the value is Q by r square. Okay. This is actually the electric field due of a spherical shell outside the surface. Okay. Now electric field inside a shell. Inside shell के inside कैसे करेंगे? Since the surface charge density is spread outside the surface, there is no charge contained inside the cell. अभी देखो जो भी charge density है, whatever the charge you have inside, due to this you have a electric field outside only na. Inside you have no electric field, right? So there is no charge contained inside the cell. Therefore the electric field inside the cell from the above formula is 0. So according to Gaussian surface inside the shell you have a 0 electric field. बाहर के लिए आपने निकाल लिया, inside के लिए 0 होगा.
अब एग्जाम की तैयारी को और बेहतर करने के लिए हमारे चैनल को लाइक, शेयर और सब्सक्राइब करना ना भूलें.